Hi YouTube. So I'm back after a long period of being sick and having other things to do, and I want to get back into the Chesscomputer series. So let's have a look at where we left off. We had made some utilities for reading a game state and printing out a game. And what I want to start looking at now is generating moves. The first thing for that we need for that is generating ray attacks. So let's have a look at, okay, that's not what I wanted. Let's have a look at what ray attacks are. So, oops. Okay, anyway, now I just had to figure some things out. So let's look at what ray attacks are. And here we have our chessboard, and let's imagine we have some position here, like, whoops. Like we have a piece here, and it's a queen. Then a ray attack is basically it's any of the attacks that a queen can do. So for example, there is the north ray attack, which is going upwards like this. Then there is the west, which looks like this. The east, the northeast, and the northwest, and the south, southwest, southeast. Okay, so basically what you do is you pre-compute a bitboard. If you remember, a bitboard is a 64-bit string where each bit corresponds to a square on the chessboard, and you put ones where the ray attack is going. And then you can use that for computations later, but for now we just want to compute this bit representation of each of the attacks. Now, as you can imagine, there will be a lot of these, a lot of possible rays, because there will be 8 rays per position on the board. So when we pre-calculate this, we need to calculate 64 different north rays and 64 different west rays, and so on. So that's what we're going to do now. Let's have a look. Alright, so the first thing I'm going to do is I will open up the source folder in Emacs, and let's make a new file called ray attacks. And so we may restructure this later, but for now let's make a structure called rays. And also let's remember to just for the sake of it, let's add it in here. And this ray structure will just contain all the pre-computed ray bitboards. So just to begin with, we'll just calculate the north rays. And as I said, there will be a north ray for each square on the board. So let's make it a vector of bitboards. So we'll just use U64 for that. And we want to just make it easy for ourselves and have like an initialize function that returns the ray. And oops. And then we'll make the north rays. Let's call it north. Okay, so the north rays will be a vector, and then we say for row in 1 to 8, for column in 1 to 8. We want to say north race push a, let's later define a function called north ray that makes the ray at this position, and that should be it. And then finally we return an instance of this array structure. So I think that's it. Now we just need to define this function, north ray, which should take a row index. Let's make it U64, why not? And it returns a bitboard. Maybe we just do like this, and then U64, replace it with bitboard. Yes. No, yes. And for now, just return 0, and then let's also just add some tests so we can see what happens. And add a test please, and make north ray, and then we will print it, and let's make one at 4.4, why not? Let's format, and now we can run it by doing like so. Okay, it did not compile because I had this guy. Let's actually run compile. Don't worry about what I'm doing now. I'm just using some built-in things in Emacs to make things easier. Okay, so we have to import it. Compile. And it wants us to, not like that, it wants us to capitalize it, so let's just do that. And now it should work. Again, it doesn't work. It's because it has to be mutable. Oops, what did I do? Mutable. And it worked, and you can see here it printed as 0. Okay, which is the return value of the function. Great, so now let's actually make this bitboard. So let's say that we begin by making a like 0 initialized bitboard, and then we want to say for so a north ray is just going up, which means we just increase the column size. So we go like from column size in 1 to 8. So basically we want to define a function called set bit, and then we want to set the bit in the bitboard at row plus offset. So we're going off equal to 1. Right, and then we return the bitboard. Now the problem is if we go outside the board, so let's say if row plus offset is greater than 8, then we just break, and that should do it. Now we just have to define the set bit function, which takes a bitboard, and it takes a row and a column, and it returns a bitboard, modified bitboard. And then we want to say, we take the values that are already in the bitboard, and then we also add a 1 at the given location. So we use 1 indexing for these rows and columns, which is why we have to subtract 1 here. And then we simply convert the row and column into the flat index, which is done like this. And then we shift the 1 bit. So let's try to run that. Now we just get some weird number. Let's actually make this a little bit better. Here's the bitboard. And then we try again. And we also, you know what, let's do like this. Oops. Here we go. Now it looks super nice. Now the bitboard is just a U64 integer, so it's like not very nice to look at. So let's also define a function that just shows it. Actually, maybe we already have that. Do we? Not in here, maybe in game. Print, show. Okay, so I don't think we have something for just the bitboard type. So I'm just gonna define it now. And I think we want this. I also want the option to like mark a position. So like each of the arrays are defined from a given position. So maybe we want to mark that. So let's just have that option. And usize, why not? And let's return a string. So maybe it's more like bitboard to string. Okay, so I'm just gonna do it like this, where we have we calculate each row one at a time, and then we add them to the board. This is just how I do it. So first we want to get the value out of the bitboard, and you can do this like so. We just get the bit value at position I, and now we want to have some way of indicating this value, and let's say that if the value is 0, then we say it's just a dot. Otherwise, it will be the value to string. Okay. And now, basically, we want to say push this thing. However, we don't necessarily want to push S. We also want to consider if we have a mark. So let's say if we have a mark at some index, then we want to say if we are at that index, then we push like an X or something. And otherwise, we push this guy, and I think that's it. If there's no mark, then we just push the string again. This is a little bit of repetition, I guess, but whatever. So away with that. And finally, we have that every time we've gone through a row, then we want to add a new line. We want to put the row in the top of the board and to clear the row. Then at the end we return the board, and I think that's there's something has gone wrong. I think it's like this. Let's format it. Expected colon from keyword match. Format. Okay. Looks good, I guess. Go away, Emacs. And now instead of just printing the raw bit board value, we can now call bitboard to string. If we then run this, it does not work. Okay, it's because we need a reference here. And let's just add no mark. Okay, looks like it worked. Have a look at this. So this is the board, and we're starting from the 4-4 position. So 1, 2, 3, 4, 1, 2, 3, 4, and then it's the north ray. It's going up. So that looks correct. Let's just try another one. Let's try in the lower left corner. And that also seemed to work. Great. And I think that's it for the north ray. Let's have a look at the other rays. All right, so now basically we want to do this again, but then just like have east ray or whatever. But you can see there's a lot of code repetition, so maybe we should make a macro. Maybe I use macros too much, but let's do it anyway, because I like macros. So I want to generalize this piece of code where, or rather actually, I want to generalize this piece of code. So let's put that in here. And I want to have some input, and I want to return this. But actually, I want to return also a value from this. So let's call it raise instead. And then at the end, I just returned raise. And the thing I want to generalize over is this function. So let's call it ray function. Ray function, it's some identifier. And there we have it, I think. So now I should be able to say north raise is just make a raise using this function. See if that works. Just compile, run the tests again. It worked. So that was nice and easy. Now I basically want to say the east raise should look like that. And we add another field to the struct. And okay. So how do we make the east ray function? So if you recall the east ray was something that was like starting from here and then just going east, going right. Can you not do that, Emacs? Okay, whatever. So it like starts from some point and then it goes to the right, also known as east. So we want to have so let's let's do it the dumb way, or the whatever, the simple way. like so. But maybe we begin to see a pattern here that we're going to make a lot of these functions, and they look very similar, except for this thing in here. So of course I'm going to make a macro, because we love macros. So let's call this macro define ray. Oops, that was not my intention. Okay, there we go. I think let's zoom in once more. There we go. Stop. Perfect. So here we go. I want to generalize this guy. So let's plug in that code. And for now, let's just get it formatted like so. Okay. So first of all, the name has to be more general. That should work. And then let's say okay, so this check doesn't work in general. So I'm actually gonna move it in here and just say if row is less than 1 or row is greater than 8, column is less than 1, column is greater than 8, then we just return the bitboard without changing anything. But that doesn't work because it's unsigned, so it can... yeah, we're gonna have problems also with going under 0, so let's make it a signed integer instead. And now I'm a bit worried that it's not gonna work. Let's try to compile it. Unused macro, mismatched types. Okay, let's... Okay, these guys are then turned into this. Again, we have mismatched types on line 53 because of the copy paste. All right, great. So it works now. And let's get on with the generalizing. So now it just tries to set the bit, but if we go outside the board, then it doesn't matter. And now this thing has to be like generalized. So maybe we need something else. So let's say we have let's say we supply some function, and that thing returns a tuple. That is the row and column. So maybe like this. And then we just say row col right. think that's gonna work. And then we can write the north ray function like this. So it's going to be called north ray, and it's going to take a function of row, column, and offset. And it's going to return row plus offset and column. Let's see if that works. Did not work. Okay, it's because the macro has to be defined before we use it. Okay. So of course we have to add the function here. Great, it worked. So now the whole point was that now we can like define an east ray. So that's one where we go right, so we like add columns. Then we can define a northwest ray. That's one where we decrease the row number, but no, sorry. We go north, so we increase, but we go west, so we decrease. And then we can define north. So we increase row, we increase column, and can define west. That's one where we just decrease that one. No, sorry, we decrease the columns and we leave this one alone. And then we have south, southwest, southeast, south, southwest, southeast. And west is again, you decrease the columns, and east you increase. So format, compile, and it seems to work. Okay, great. So now instead of copy pasting this piece of code a bunch of times, we just defined a macro and then we could write all the functions very simply. But let's just check that they also work. So now we want to have, how many do we need? We need 8. So 1, 2, 3, 4, 1, 2, 3, 4. And then we want northwest, northeast, west, south, southwest, southeast. Southeast and east, northwest, northeast, west, south, southwest, southeast, formatted, and 1, 2, 3, 4, 5, 6, 7, 8. There is a lot of copy pasting, but at least thanks to macros, we reduce it a little bit. And we format again. That should do it. 4, 5, 6, 7, 8. West, south, southwest, southeast. Stop it. Format. And now let's try to just make it compile. It compiled. But let's check the other rays as well. Not like that. Like this. You know what? Let's put it like in the middle. And let's say 5 times 8 plus 4. Let's also put a mark. 2, 3, 5, 6, 8. Formatted. And now we make a, actually, I regret that. Let's say print north ray, and then let's say we actually try to use this initialize function we defined, and then we print rays.north ray. And this is the function I want to copy. So 2, 3, 4, 5, 6, 7, 8. And then I want to say northwest. Probably I should define some better way of testing this stuff, but let's just do it like this for now. And south. What did I do? Ah, okay. Whatever. Southwest. Southeast. And what am I missing? I just have a bunch of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Compile. Does not work. Ah, shit. Okay, so here's the problem. We want to look at the rays at some index. So let's do something like this. Show whatever, and then we say the index is 44. Index is 44, and I'm not trying to call the raise function, I'm just going to say it should be raise, and then it should be the index, like that. And then for good measure, let's also replace this guy with just the index. There we go. Let's try that. All right, great. So we are at index 5.4 should be. So 1, 2, 3, 4, 5. Clearly something went wrong. Six. 1, 2, 3, 4, 5. What's 6? But 6 times 8 is 48. Okay. It seems there's some kind of problem with the indexing, but whatever. Let's just leave it for now. Let's try to see if we get what we want. So we get the east ray here, the north ray, northeast, northwest, south, southeast, west, southwest. So we get all the rays we want. It's a little bit hard to see. We can kind of see that it's correct by comparing with this. Like the last one is west and then southeast and then south, which is the order we get it here. But obviously it's not ideal. Now let me just try to figure out this indexing bug. Okay, I just realized there's no bug. It's just that I thought about it wrong. So let's say that we want to look at row 5 and column 4, then the index should be row -1 times 8 plus column. And I forgot that you have to do this -1. So yeah, that's it. And now the north ray should be in the correct position. North ray, so 1, 2, 3, 4, 5, 1, 2, 3, 4. So it was correct, I just had the indexing wrong. Alright, so that's it for now. So now we basically pre-calculate all these array attacks. And then in the next episode probably we'll try to look at what we can do with this stuff. Like calculate which pieces are attacked, things like that.